Abby and Ben did household chores last weekend. Together they earned $50. That looks like an interesting statement. Let me underline that. Together they earned $50, and Abby earned $10 more than Ben. So they also tell us, let me underline that, Abby earned $10 more than Ben. How much did each earn? So that's the first question that we have to answer. And they say, if you were to use the graph above, and I put it on the side here, which strategy is most useful in helping you find the answer to the problem? So there's kind of a meta level question of how do we answer that first question? Find an equation for the blue line, red's y-intercept, find the points of intersection. Fair enough. So let's just think about that first question, then we can answer this later, depending on how we answered that first question. So that first statement, together they earned $50. What does that tell us? Well, if we say that if we say that Abby's earnings are represented by A and Ben's earnings are represented by B, that tells us that A plus B must be $50. So A plus B have to be equal to $50. Abby's earnings plus Ben's earnings are 50. Together they earned $50. That's all that statement is telling us. And if we see how they graph things here, on the vertical axis, what we normally associate with the y-axis, they graphed Abby's earnings, or this is Abby's earnings right there. So we could say this is the a-axis. And then on the horizontal axis, what we normally associate with the x-axis, they've charted Ben's earnings. So we could say that this is the b-axis. So if we were to just map this into the traditional slope-intercept form, we don't have x's and y's here. We have b's and a's. So we just want to express a in terms of b, the vertical variable in terms of the horizontal variable. That's just like the y equals mx plus b form. And the easiest way to do that is just subtract b from both sides of this equation. And we get a is equal to negative b plus 50. So in this situation, you have a slope of negative 1. Let me write this down. Slope of negative 1. That's what's multiplying the independent variable. And then you have a y-intercept of 50, or maybe we should say an a-intercept. But I'll write y-intercept because that's what we're familiar with. You could view this as also like the y or the vertical axis. Y-intercept of 50. And you can see they graph that. You have a a-intercept or y-intercept of 50, and the slope is negative 1. If we move 20 in the positive x direction, we are moving down 20 in the or we're going 20 in the negative vertical direction, or in the negative a direction. If we go 50 in the positive, I shouldn't say x direction, the positive b direction, we go down 50 in the a direction. So the slope is negative 1. So this red line right here is the graph that depicts this first constraint. This first constraint. And it's important to realize that, look, all this graph shows is all the different possible combinations of Abby's and Ben's earnings given only this first constraint. Maybe Abby made $50 and Ben earned $0. Maybe Ben earned $50 and Abby earned $0. Maybe they both earned $25. Everything on this line would be a valid combination of Abby's and Ben's earnings given the constraint that they earned $50 combined. Now, the second statement, Abby earned $10 more than Ben. So if we were to write that, that's saying that Abby is equal to Ben's earnings plus $10. Abby earned $10 more than Ben. And here the slope is 1. Slope is equal to 1. You see that right there. There's an implicit 1 multiplying times this b. And then the y-intercept is 10. Y-intercept is 10. And they graph that here. The y-intercept is 10, and the slope is 1. You move 10 in the positive b direction, you move up 10 in the positive a direction. So this blue line represents all of the possible combinations of Abby and Ben's earnings if you only had this constraint that Abby earned $10 more than Ben. If Ben earns $0, Abby earns 10. If Ben earns $10, Abby earns 20. If Ben earns $60, Abby earns 70. Now, we aren't dealing with only the blue constraint or only the red constraint. We're dealing with both of them. We know that both of them are true. So whatever earnings Abby and Ben made, they have to satisfy both constraints, or they have to sit on both of these lines. Now, what is the only point that is sitting on both of these lines? Well, the only point that sits on both of the lines is the intersection of those lines. That point right there is a valid combination from the point of view of the blue constraint that Abby earned $10 more than Ben. And it's also a valid point or a valid combination from the point of view of the red constraint that Abby earned Abby and Ben earned $50. So that point represents Abby's and Ben's earnings that satisfy both constraints. And we can eyeball it right here. It looks like Abby earned $30 and Ben earned $20. And that makes sense. Combined, 20 plus 30, or 30 plus 20 is $50. So we meet our first constraint. And we see that Abby, $30, made $10 more than Ben, who only made $20. So if you look at the point of intersection, you will have solved the problem. Abby made $30, Ben earned 20. So answering this second, so we know the answer. So Abby earned $30, and Ben earned $20. Now, answering the second level, meta level question, which is the best strategy, we see, well, we had to find the points of intersection. So that is choice C. We had to find the line's point of intersection. Finding these other things really wouldn't have helped us solve the problem.